understand how to find the tensions in the various strings through one more example, and how we can use Lami's theorem to our advantage, which saves us time also and which gets to the same answer. Let's take the case where we have a 10 kg block which is hanging from a support like this. This and this, they are two strings which has been knotted over here, and from here, that is 10 kg block is hanging. We are supposed to find the values of T1, T2 and T3. To find the value of T1, T2, T3, we follow our good old method of free body diagram or force body diagram technique or force diagram technique, where we have three steps. First is isolate the body, second is draw forces onto the body, and third is apply F is equal to ma, where F stands for the resultant or net force. So what we do is, first is we draw a circle onto this to isolate this body. We have isolated this body 10 kg, and then we draw the forces onto it. Then obviously we see that is Earth is going to pull it down with a force of 100 Newton. Earth is going to pull it down with a force mg. Mass is 10, g we are taking as 10 meter per second square. So the downward pull, it experiences 100 Newton in this direction. Obviously this circle diagrammatically cuts this string over here, and we know that its tension is always outward away from the body. So let's call it T3. So T3 is in this direction. We also consider this knot as a free body, and onto it we draw a circle. So our focus is on this body. This knot is our free body. When this knot is our free body, then obviously it has three strings attached to it. One string, second string, third string, and all the tensions, they have to be outwards. We know that its tension is always away from the free body. This is a free body we are talking about. So T1 direction is this, T2 direction is this, T3 direction is this. Now because this is stationary, this block is not moving up or down. The acceleration of this block is 0. Because the change of velocity is equal to 0, this is stationary and this remains stationary. It means acceleration is equal to 0. If acceleration is equal to 0, if we apply F is equal to ma, if acceleration is equal to 0, the net force has to be equal to 0. It means the downward forces, they have to equal downward upward force. So T3, it has to be equal to 100 Newton. So from here we get T3 is equal to 100 Newton. So one value we have found out. So now the problem is to find the values of T1 and T2. So what we do is we can use resolution of vector method to find the value of T1 and T2. Obviously, if this is 30-degree angle, this and this line, they are parallel. We have taken this as x-axis, this taken as y-axis for the ease of purpose so that we understand it. 30 degree is here, so this is also 30 degree. If 60 degree is here, so this is also 60 degree. Then what we do is, this is purely, let's say, in the y direction. T3 is in the y direction, and that is obviously equal to 100 Newton. So this breaking the forces, resolution of forces, this comes over here. That is how it has been shown. T3, that is equal to 100 Newton, is in the downward direction. So now what we can do is we can break this tension T1 into its component. One is along the x-axis, the other is along the y-axis. This way, this 30 degree, so this comes out T1 cos 30. And this comes out to be T1 sin 30. We have done this in our earlier cases, in our earlier classes of resolution of vectors. So obviously we resolve it. We resolve this vector which is stuck between x and y axis into the components purely along x and y axis. The x axis component comes out to be T1 cos 30. So this is T1 cos 30. Its vertical component comes out T1 sin 30. Similarly, in this quadrant, we have tension T2 in this direction. So its components will be, one is this direction, the other is going to be in this direction. This direction is T2 cos 60. This component is going to be T2 cos 60 Newton, and this is going to be T2 sin 60 Newton. Remember, tension is always only a force, as unit is going to be Newton only. And in the downward direction, we have obviously 100 Newton. That is 100 Newton we have found. T3 is equal to 100 Newton. So now this knot over here, that is this knot over here, this knot represented over here is stationary. It means it is neither moving along the x-axis nor moving along the y-axis. It means the forces, they are balanced along the x-axis also, along the y-axis also. Or we can say that is summation of forces. The net force along x-axis is equal to 0. It means this side forces, they have to be equal to this side forces. It means T2 cos 60 is equal to T1 cos 30. We can put the values. Cos 60 is 1 by 2. Cos 30 is root 3 by 2, and similarly, so from here we get the relationship T2 is equal to T1 into root 3. Similarly, along the y-axis also this is not accelerating. So we say that is net force along y-axis is equal to 0. Summation of forces along y-axis is equal to 0. So it means T2 sine 60, T2 sine 60 plus T1 sine 30. It has to be equal to downward forces. So T2 sine 60 plus T1 sine 30 upward forces, they are equal to downward forces. Net force along the y-axis is equal to 0. T2 sine 60, we put the value of sine 60 as root 3 by 2. Sine 30 is 1 by 2. We can put the values. T1, now we can substitute. T2 is T1 root 3. So we substitute. T2 is equal to T1 by root 3 over here. And this comes out to be, T1 comes out to be 50 Newton. So once we will get the value of T1 is equal to 50 Newton, we can put it over here. So this is T2 is going to be 50 root 3 Newton. We can get the answer.